gonna dock that here for now, because really those windows always switching their positions is really a bit annoying. And let me do it that way. I do still want to see the attribute editor later, so let me leave that free for a moment here and let us just lock the interface again. And that's that. So the IPR is running, and we're gonna start at the end here. So basically you're reading these things from left to right. So this is all that's inputting into the right side, and basically this thing here, which I already mentioned, the shading group, is basically assigning the thing, the shader network, this whole thing here. So this is the last node. This is actually a shader. As I said, this is basically the master mix shader for this material. This thing is assigning this shader to its respective shapes. So basically that says, so you're on this object, this object, this object, and these faces of this object. So that's nothing more than that. So what I want to start with before examining that network is usually, if you've built a shader and designed a material, if I switch to the attribute editor of this shading group, usually you'd have your shader assigned here. But you can see that in this case, my fuselage dirt mix shader is actually assigned to the Arnold tab here in the surface shader, and there is another material assigned to the surface material. Why did I do it that way? Well, basically, this shader and basically almost nothing from all of these inputs can be displayed in Maya's viewport. So basically, I'd see a dark black plane for the majority of the time. If I wanted to turn on texturing, which I'll do just now for a moment, I'd see nothing. So I wouldn't be able to see my textures. If you're animating the thing, you might want to see where certain markings are or something like that. So you kind of like to want to have some orientation on how the final asset will look like rendered. Even if it doesn't come close to the final look or that close to the final look, you want to see that. So basically in Maya, you have this ability to assign another shader to your renderer output than to what is being displayed in the viewport. So this basically tells Maya, this is what you're going to show in the viewport. If you are exporting to Arnold, which we are, if you use other render engines, they would also be here. So for each of the render engines that you're outputting to, and on production it actually happens a lot that you might be outputting the same thing to two render engines for various purposes. It's not that common, but it can happen. So basically you're telling Maya, if you're exporting to Arnold, use this shader for Arnold. So Arnold will only get this one, and another renderer might get another shader. So basically this is how I'm circumventing the limitation that my shader that I've built can't even be displayed in the viewport. Instead, this shader, this is assigned to the surface shader of the shading group right here, is basically a little model, a little child version of my actual shading network. So basically what this does is just loading the textures from the hard drive. So basically this metallic mask and the albedo color. And then it's just taking them, multiplying them so that I can see my color texture wherever this thing is not metal. And wherever this is metal, this is just using a gray a gray color, which you can see here. So in the end, I do have a representation of my material on the object for the viewport, and this is why this is called VP, viewport shader. So I usually call them VP, so I know that it's just a viewport shader. I don't need it for the final asset. It's just used as a convenience node to see something in the viewport. So basically that's that. This is still a Arnold shader, because really they can be displayed. But that could be any kind of shader. It could just be a standard Maya Lambert or Blinn, whatever you want to use. So I decided on a Arnold shader because if you don't use nodes that can't be displayed in the viewport, they are represented in the viewport quite well. So basically that's the reason why I also used an Arnold shader for that viewport representation. But this is never going to get rendered. This is, as I said, this is just a convenience node. What is going to be rendered is this thing here. And as you can see, here are other shading groups. So within these graphs, there are other materials that are basically taking the same input, but are basically a little variation of that shader. Or, for example, also this blue nose shader, which is basically connected to the majority of the inputs that I have, but there are a few things different. So basically, they are this shader is assigned to other objects. So basically, just the rudder back here and the nose right there. So that's just another shader that is assigned to different object, but it is here in the same network because basically it's pulling the same textures from the hard drive. So it's just easy to just lay that out in the same network, really. So, but what is our main shader? That, as I said, that's basically the shader that is on the main part of the fuselage here. That is this mix shader. So what we're going to do is basically walk backwards from this shader to the beginning of the network with isolate selection. And I'm going to skip a few nodes because really not everything is important here. For the people in my course, you can, of course, take a look at them. But I'm going to skip over some parts here. So the basic layout is this. And let me just get a bit larger here. Let's make that full screen and maybe take a look at it from this angle, maybe, or something like that. So we can see most of the plane, even with limited screen real estate. So this is a mix shader, and a little word about mix shaders, they are expensive. So basically what you're doing is you're mixing two materials together. So basically the renderer has, with a few optimizations, but wherever those materials are mixing together and there is not fully one or the other material, this thing has to kind of like on render time evaluate two shaders at the same time. So basically it has to do a lot of calculations twice. It doesn't really do them twice, but it kind of helps to think about it in the way that it does. So basically you're doing all your calculations twice. You're not, as I said, but almost. So this thing is expensive, more expensive than if you would have one shader on your surface. But there is a good reason why you sometimes use mixed shaders. You can of course vary surface attributes on one material. So you can control the specular roughness. You can also decide on the metalness, so whether it is metal or not. So for a majority of the surfaces here, I could have done that. But in the end, this is also about how easy it is to work with things. And sometimes it's just easier to say, I'm going to live with the bit more expensive shader, but I can think and construct materials in a way that kind of like mimics nature. So if I have a metal, and this metal is pretty much clean, it has a few bumps, as this plane has. You can see all those little reflections here are a little bit bumpy because in real life, this material has little bands and little dimples in the surface. So basically, it's kind of like kind of like a noisy surface. So in the real world, when this engine exhaust is basically kind of like exhausting particles onto that surface, the surface is gonna get rougher. That I could control with a single shader by controlling the roughness of this shader. But in the end, the surface basically gets another color. It gets a more rough material. So basically, this dirt on the surface and some dirt stains, some oil stains, or something like that, is basically more like a second material in real life overlaid on that metal. So it makes sense to kind of construct your shaders in the same way. There are reasons and pros and cons for every kind of workflow. In the end, my decision usually comes down to how expensive is it to how expensive is it to set up. So if I have to triple the amount of textures that I have to paint to maybe get everything done in one material, and I'm going to spend hours or days on that even. But I'd be way faster with maybe just half or a third of these maps by using different materials, and it's still going to render fast. I'd probably go the route where the computer, so the rendering, has to do more work than I have to do, because in the end, computer time is also a little bit cheaper than basically human work time. So It's a kind of like a pro-con decision, and then you decide. I would never tell you to never use mix shaders, but you got to think about whether you have to use them or not. I'd not put a mix shader on everything because you will slow things down. Not always considerably, but a lot. But anyway, this is a mix shader. This is called the dirt mix, so you can basically extrapolate what this is doing. So let us take a look at one of its inputs. So there's this fuselage master mix material, and with isolate selection on. So this is the master dirt mix shader, so you can take a good look at what the surface looks like. And I'm going to select the fuselage master mix, and you will see that some things will have changed. And basically what has changed is the fact the airplane is not dirty anymore. So if I zoom in here to the engine exhaust, you will clearly see the difference. So there's this dirt material overlaid everywhere. So I'm just going to isolate the selection right here. There's this dirt material overlaid basically everywhere. And without the disk mask, this is just a clean fuselage. There are bumps in the surface, of course, but basically all of this grayish, yellowish dirt on the surface is basically missing. So as you can see, there's these little dirt stains right there. So a mix has another input. So this is one input of this mix. The other input is the actual mask that is responsible for controlling where the surface is dirty and where it isn't. So this is the mask. So I'm on isolate selection. This is just a black and white input. So this mask, of course, only takes a black and white input. So one float value to say, well, where you're white, you're using this material, where you're black, you're using this material, everywhere between you're using both. So this is the output of my whole group of shaders that are basically generating this dirt mask. So if I step through them, you can see there's this kind of noisy surface. There are stretched noises that are mixed with a curvature shader. So this right here is a curvature shader. And this curvature shader is controlled in turn by an AI noise, so basically this texture here. And this is fed into the radius of this curvature shader. So the curvature shader is searching or looking for bends in the surface or taking a look at the curvature of the surface. And wherever there's high curvature, so things on the surface make a sharp turn, like at the end of these panels here, it's gonna be white, and wherever the surface does not, it's gonna be basically black. So this radius, how far it is going to look for curvature, how far away is the next surface, how bendy am I towards the surface, basically, is controlled by this noise. So that leads to there being based on that noise, a larger or smaller search radius. So this irregular structure is beginning to evolve from that. So I'm crushing that, so basically changing the values on that. I'm clamping that between the range between 0 and 1, because Arnold, of course, is also just calculating all of its colors in 32-bit floating point. So there can be values above 1, basically, and even below 0. So I have to kind of, as a precaution, I don't always have to, but you should really, when you're just dealing with something like an alpha mask input, I'm clamping between 0 and 1 to not have any negative or positive larger than 1 values right here. And this dirt mask is also adding in another input, and that is this dirt mask texture that I've prepared in Photoshop. And you can see these are our whole UDIM tiles of this dirt mask texture applied to the whole plane. And since I need another range, basically, I'm just inverting that, basically. So I am basically reversing the values. So it's 1 minus the values in that texture. So everything that's black, it becomes white, and everything that's white becomes black. And I'm just adding it to the thing I've created here. So basically I've added white where the engine is. The same texture is here on this this engine exhaust material. But as I said before, this is a different material because a lot of properties on that part of the plane are different. This is a slightly darker material, it's a slightly different metal than the rest, so this is a different shader, but in the end this gets the same mask. So this mask is also feeding right through here, down here, and this is also basically in that way applying this mask to this other shader. So that's basically it for the mask. Pretty straightforward setup, really. And the other thing that is mixed into this dirt mask material right here, down here, is of course the dirt shader. The dirt shader is right here. So basically this is just a darkish brownish material. It currently is pretty reflective, which works for some shots, and for the shots that I did, it kind of looked like the reference. But usually dirt, a dirt material would be kind of like brownish, reddish, dark, almost black mainly, and it would be a little bit rougher. But I didn't do that yet because I wanted to have control over this roughness of this material basically later on my rig, because on a per shot basis I might decide on how dark the dirt should appear or how rough that dirt should appear. So basically how much of it you can see. So basically if the plane is reflective and the dirt is reflective, the dirt will not come through as much if it was rough, because basically you're changing two surface property. So the color is going to change and the roughness of the specular reflection is going to change. So that's kind of like more visual cues that there is a different material. So you kind of like tend to pick it up a lot more than if only the color changes and the specular stays the same. So this is something I would like to do at the very end of this. So I'm going to change again the rig a little bit. It's going to take 5 minutes or something, but just to show you the concept on how you can control properties on your materials from the rig mainly. But this is the dirt material, and this is of course based on a mask mixed together with our main fuselage material. So the next material we're going to take a closer look at is our fuselage mix material, and probably then just that metal material where you can see that everything that's painted is not present here. So responsible for mixing this metal with the paint is this fuselage master mix, which comes before the dirt mix, but because, well, basically everything on this side of the mix is basically what the plane look like when it comes from the factory, minus a few dirty stains and color chips here and there. This is basically what it would look like clean. That's not anymore. So let's take a look at that one. So the fuselage master mix, of course, has also an input, and these three inputs are these here. So the first thing I'd like to take a quick look at is basically the mask for that thing, because that's pretty simple. That's just the texture that I painted, this metallic mask, loaded from disk. It's basically used as it is because that was painted in Photoshop and it fits the plane quite nicely. So there's also this AI noise, which is then again through a AI range crushed so that there are just little dark spots. And then I'm using this noise to basically kind of like fade away this mask material. So through procedural means, I'm adding to my painted texture some more paint chips. So wherever this texture, of course, is black, there's going to be the metal material. So basically that means wherever it is now black. So if we take a look at that part over here, so there's no paint chip here, but after the multiplier right here, there's this missing part of our paint basically, so the metal is going to come through. So that's basically where paint has been chipped off. So that's the mask for that thing. That of course covers the whole plane. The stripes here, the invasion stripes on the wing, and yeah, basically every surface there is. So I get these little paint chips everywhere, which just brings a little life to your asset. So in reality, depending on how old that plane is, how many missions it's flown, actually, there would be more or less paint chips, so you could kind of like vary that from shot to shot if you really wanted to, but maybe probably you won't, because what's really going to impact the look of the plane is kind of like how much dirt you're mixing in, not how many paint chips you're mixing in. You should use that sparsely and carefully. So in the black and white mask, these seem to actually be a lot of spots. So normally you wouldn't use that much on that plane. With the textures it has, they are not that obvious. So I pushed them a little bit more just to have a bit more variation on the surface than there would probably be in reality. So that's that mask thing. So coming over here, this is the fuselage unpainted material. So that's basically everything that is metal on that plane. And as you can see, that's a rough, bumpy metal surface. Well, not really rough. It's reflecting clearly. At the moment, I can vary that. It's one of the properties I can control from the rig, so we can take a look at that. But a real P51 straight from the factory is a clearly reflective, but it has bumps in the surface. So we can see all these little bumps right here. So if I take a closer look at the wing at an angle, you can see that the whole surface basically has these little kind of ripples, and that's what a plane looks like unpainted, basically. So this is of course a bump map. So looking at that material, let us quickly take a look at something that's right down here. So this is just the normal camera input. Basically, normal camera is a fancy word for bump input, but because it is changing the normal of your surface based on a texture map. And if we follow through here, this is not connected to that. So some lines are crossing here, unfortunately, but you can't have it any other way. So if we follow that green line over here, we can see there's this bump 2D node. It's an AI bump node. We can't really take a good look at that because what we're seeing here are normals that are changed, but that's really not that much of a thing that you can understand visually as a human being. What you can understand, of course, is basically what's feeding into here. So there's, of course, the bump map that I've painted. So those are all the rivets. This is nothing procedural. This is just a texture map loaded from disk. So this is basically adding to the bump, to the bumpiness of the surface. So all those little rivets will be pushed in a little bit, and you will see them in the rendering. And if I go back to the shader here for a moment, which is this one, you can see that there are these little bumps for the rivets. So if we go back here to the very beginning of that thing, this bump input is actually being fed another normal. So basically we're adding bumps by combining bump inputs. So connected to this AI bump 2D is connected another AI bump. And as I said, we can't really visualize them in any meaningful way in the render view. But what we can again visualize is the bump map that's going in here. And that's just a noise. So basically that's the structure that is making the plane appear as an uneven surface. And this bump has another bump input, which is also another map that I'm creating procedurally. And the reason why I'm connecting bumps and not just adding maps is basically that on those bump 2D nodes, I can still control the height. So basically the intensity of the bump map that I want to have. And I like to do that in terms of bump height instead of mixing textures. It just kind of feels more natural. You could add all those textures together, or maybe not add them, but overlay them, subtract them, whatever. Any kind of math that you can use to combine textures with each other. In the end, it's easier to layer just a few bump 2D nodes because the control is kind of like more intuitive. So yeah, if you want to work that way, you can. So this is just a larger noise. So this is basically creating larger dimples on the surface. So basically this thing at the front here this whole setup right here is responsible for making this setup bumpy. So if we take a look at that again and zoom out a bit, we can see that the whole plane has these, especially on a sharp angle like this or something like that. You can see, for example, in the propeller, in the reflection of the propeller on the surface, how bumpy that surface actually is. So yeah, taking a look at reference routers, the P51 is pretty bumpy. So that tries to kind of mimic that behavior. So the other material, of course, and let me quickly turn off the region here. The other material is, of course, and I believe it's down here. So it's been a few days since I created that shader, so I might have to search for a few things here. This is the fuselage painted material. This is basically, so if we follow that line down here, this is the other input of our fuselage mix. So that's a pretty simple material. So let's take a look at that now. So this shader is basically just also a AI standard shader. It has roughness, it has diffuse color. So the diffuse color is the actual painted albedo color. So you can see that if I move a little bit closer here, let me put it back up here, I can do that in a render view. It has all this paint detail that I painted in Photoshop actually for the surface. So if I take a look at the wings here, there's this little stripes and then some irregularities in the surface and some warning signs, some fonts. So basically the names of the crew of that airplane, and of course the name of the airplane itself. And there's also just some black spots. So this is basically where there is where the tail number is, basically, and the identifier of the plane and its squadron, and the serial number and stuff like that. So since the mask is kind of like deciding whether the font will be visible or not, since the font is black, I can just put a fully black square or part there in the text, in the color texture, really, because the font is coming from the mask. So I don't need to have the font itself in here. So the other thing this has, of course, is some noise for the specular roughness, so that the specular highlights get broken up and they're not the same overall. So you can see that here in the reflections, probably more on a higher angle, that there's a little bit of variation there. So this is just bringing life into the surface. And of course, this is getting the very same bump maps that our actual metal material is getting, because this is the same surface, just painted, so it's getting basically the same bump map. So one thing that we haven't talked about on the fuselage unpainted, which is basically the metal part, is of course also has specular roughness. So this is just not a completely even surface, but this has some variation in the roughness. So if I take a look at that, this is feeding into here, and basically we're currently switching. If I zoom out here, so this is the fuselage unpainted, and this is the painted material over here. So we're basically switching or basically controlling the roughness with this output right here. So this is coming from up here, right there. So this kind of like group is responsible, as if you can take a look at these nodes here, they're called panel seed from rig, rough min, and rough max from rig. So these things are kind of like little connectors to our rig. So they are fed values, which you can't see here because I don't want to see the rig stuff here. But basically those get fed some values by the rig, and they're putting it into some Arnold shaders, which we'll take a look at the moment. One last thing that I wanted to look at is this dirt shader. So you can see this thing over here, which is kind of like an oil stain. So on a lot of photos of P51s, you can see there's this kind of like oily surface there, and basically this is in this case just coming from the color map of that material. So this is the color that's feeding into this fuselage dirt mask, and this again basically has some variation, and it has this oil texture, which in return is using the dirt mask, which I've loaded. The dirt mask is being crushed to kind of like limit it to a certain area. And then this oil stain material, or color really only, is then multiplied by that to be only limited in the area where this kind of like oil stain surface would actually appear. So let me just move that over here real quick, because there's a lot going on over here, but really there was no real other place I could put that, so it's a bit messy right here, but that's the way it is. So this oil stain thing has a thing called AI switch oil method. So a switch can decide based on an input which is this one, which of these nodes to use. So basically there is some method that I can tell it, use input 0 and feed it through, or use input 1 or input 2 or 3 or 4 or any of the others really. And again, this switch, this is called oil method, and I'm going to explain that a little bit later. This is also controlled from the rig. So there's this oil method from rig. So we're going to take a look at that as well in a moment. And without going into many more details of the actual setup, this is basically it. So this is basically the things that are combined to create the final look of the plane surface. And this is kind of like the base look of that plane. So this is how it would appear if you just loaded the file. But it can be changed and it can be varied. And the way I decided to be able to bring some variation into that plane's surface to change things up a little bit from shot to shot, or maybe, well, if you would be doing a movie about a World War II pilot and his plane, which is called Miss Elliot, and you wanted to tell his story, the story of him and his plane, from maybe when he entered the war and got his first plane to maybe when the war was over and he returned home, which isn't the most dramatic story, but yeah, you kind of get the gist of it. So basically, when he got his P-51, it would be clean. So you kind of like over the course of the film, you would be changing that asset from shot to shot. For example, it may become more dirty. Some parts might have been changed, so there might be worn down surfaces, and there might be clean surfaces. When the part is replaced and the metal overall is used, but maybe was just one whole panel is replaced, you would have it very clean. So basically, you have to have ways to change an asset over time in a movie. So most of the time there will be just like 4 or 5 variations in textures of that asset. So texture artists will maybe have painted 5 versions of the texture, and maybe you would also have 5 versions of the model, where maybe you would model into the model some of the bumps that the plane has gotten because something bumped into it or something like that. Or you could keep it procedurally and just minimally change things from shot to shot. And as I said, I decided to control certain things from the rig. And I already mentioned it right here. There are a few nodes that are taking inputs from the rig. And let's take a look at that now and see how that is actually done.